So chapter 7 is number sense, rational numbers, and irrational numbers. And don't worry about it. So number sense, in all honesty, number sense is going to be things like which number's bigger, which number's smaller. You get into prime numbers, stuff you saw last year, prime numbers, composite numbers, that sort of things. Rational numbers, we'll talk about that towards the end of the chapter. So rational numbers. Rational numbers are pretty much all numbers you've seen so far. Irrational numbers, we don't really cover it. It just talks about it very briefly in one section. It really just mentions them as says pi is an example of an irrational number, and so is square root of 2. And other than that, the book doesn't cover it at all. But this first section is review. If you did the Math 7 last year, Chapter 3, Section 6 of Math 7 is the same thing. So it's divisibility rules. And by that, it looks at how can you tell fairly easily, is something divisible by 2? Is something evenly divisible by 3 or by 6? And so on. So divisibility rules, actually it's divisibility patterns, but divisibility rules and prime factorization. So one person recognizes it based on the response.
Yeah.
I like... Oh, really? Well, that's probably why they put it in the math in other years, to give you more practice with it. But it's the factor tree things. I think they're kind of fun, but I like math. So Roman numeral 1 is going to be terms. My guess is that you guys will probably do well with this stuff. Divisibility rules are just kind of hard to memorize, all of them, so we'll have to kind of work at that. But going to start with the terms.
Okay.
And first thing we want to look at is prime numbers. So prime numbers. And prime numbers are going to be integers larger than 1 that are divisible by 1 and themselves. Maybe I should say that are only divisible. So prime numbers, integers larger than 1 that are only divisible by 1 and themselves. So first example would be 2. So I'm going to write an example, just list a bunch of them down there. So 2 is going to be a prime number because you could divide 2 by itself. 2 divided by 2 is 1. You could divide it by 1. 2 divided by 1 is 2. 3, prime number?
Yeah.
Yep, because you can't divide it by 2. Can't divide it by anything before it. 3 is just divisible by 1 and by 2. So 4? No.
Divided by 2.
Yep, so 4 can be divided by 1 and 2 and 4. So 4 is not but 5, I heard. What's going to be my next prime number? 7, good. Because 6 is divisible by 2 and 3, so that's not. After 7, 11. Because I want to say like 9, but 9 is divisible by 3. So after 11 we have 13. Did you get the general idea? Should we keep going?
17.
So 14's not, 15's not, 16's not, 17, 19, yep. 20's not, 21's not. So okay, 23, and then I'll just do the dot, dot, dot. But feel free to keep going. But prime numbers are going to be those numbers. Numbers that are only divisible by 1 and by themselves. We all right on prime numbers? Composite numbers. For me, I think of POS. I can't talk about what I think of and write at the same time. Composite numbers. I think of like bike frames. Some bike frames, what they'll do is they'll take and combine a couple different metals together to get a composite frame. So you kind of get the properties of this metal and the property of this metal. So you get kind of the best of both worlds. Composite numbers are kind of similar to that. That composite numbers are going to be a combination of prime numbers. So something like 6 is going to be a composite number. Our book just says they're numbers that are positive, so positive integers that are not prime. So positive integers. I don't know if you remember, but integers are numbers with no decimals. So positive integers that are not prime. So 6 is a prime number. because it's, I'm sorry, 6 is a composite number because it's not prime. 6 could be divided by 1 and 6, but also 2 and 3. So if you wanted to, you could put an example. So 6, it's divisible by 1, 2, 3, and 6. You know that all of those are going to be factors of 6. So these here would be factors. And I'm using that word a little bit early because that kind of comes up soon in the notes, but not right now. Safe to go on to Roman numeral 2? The second thing in the notes, Roman numeral 2, is going to be divisibility rules. I look at these as kind of like tools for your math toolbox or weapons for your math arsenal. You know, the more of these that you know, the easier it's going to be down the road. Honestly, I'd forgotten a decent number of these, and I survived math just fine. But the more you know, the easier it's going to be for you. So what we're looking at is something divisible by 2? This is my first one. And by that we mean, if you take that number and divide it by 2, does it give you a nice number with no remainder? So like 4 would be divisible by 2, 6 would be divisible by 2, 3 wouldn't be, because 3 divided by 2 is 1.5, right? So the key is, any number could be divided by 2 if that number is even. So I'm going to write, for number 2, I'm going to say, if the number is even. And probably way back when we were young, they told us that even numbers always end in 0, 2, 4, 6, or 8. But if you're like me, you just look at a number and you kind of know if it's even. If it ends in that. All right, number 3. 3. Does anyone know this one? If you add up the digits, so the sum of the digits, so if the sum, everything's divisible by 1. So if the sum of the digits, I see what your brain's thinking though, is, anybody learn this? Is divisible by 3. Good, good. If the sum of the digits is divisible by 3. So for example, if we have maybe 576. So is 576 divisible by 3? Well, if you want to check it, you do 5 plus 7, 12, plus 6 gives you 18. Can you divide 18 by 3? Yep. So 576 would be divisible by 3. That doesn't help us find the answer, but you could at least know, is it going to work out nicely? So add up the 3 digits, or however many digits there are. If you can divide that total, that sum, by 3, it's going to be 4. Something's divisible by 4 if the last 2 digits are divisible by 4. If the last 2 digits are divisible by 4. The reason this works, 100 is divisible by 4, right? 100 divided by 4 is 25.
Yeah.
So as soon as you get to that third digit, if you have 100, that's divisible by 4. So it only matters what's after the 100. Or 200, well, that's divisible by 100, so it has to be divisible by 4. So 200 and something, it only matters the last 2 digits. So for example then, if we did something like 812, we know that 800 is going to be divisible by 4. And some of you are maybe saying it would be 200. But okay, so 12. Is 12 divisible by 4? Yep. So that's going to work. So 12 is divisible by 4. So you know that 812 then is going to work as well. All right, 5. 5 is a nice one, easy to remember. If something's divisible by 5, what can you tell me about the last digit?
0. Or 5.
Or 5, perfect. So if the last digit is 0 or 5. So if you think of multiples of 5, you have 5, 10, 15, 20, 25, 30. So they all end in zeros, the 10, 20, 30, 40. Or 5s, the 15, 25, 35, so on. 6. Do you agree 6 is divisible by 2 and by 3?
Yes.
So you can use these 2 rules for the 6. If something's even, it's divisible by 2. And if you can add up the digits and have that evenly divisible by 3, then you know it's also divisible by 6. So 6, I'm going to write if the number is divisible by 2 and the 3. Just flip to the rule above. Oops, 7. We don't have a good rule for 7. 8. 8 then is if the last 3 digits is divisible by 8. So if the last 3 digits is divisible by 8. That kind of feels like a bad rule in some ways, kind of like how helpful is that? But if you had maybe something like 4, 3, 2, 0. Because one side is like a 3-digit number divisible by 8. What's my chance of doing that in my head? But sometimes if you have like 320, is that going to be divisible by 8? Because 32 divided by 8 would be 4. If I just had that, so this here would give me 4. So if I have that 0 on the end, instead of it being 4, it's going to be 40. So then you know that 4,320 is. Or you could maybe instead, if you had 4,300 and maybe, I don't know, 52, you could try to say, all right, 352, do you agree that's going to be 320 plus how much? 320 plus what gives me the 352? Another 32. Well, you know this is going to be, right? Is 32 also divisible by 8? Yep, so then you could say the whole thing has to be. So you can sometimes hack it apart like that, but it's a little confusing sometimes. All right, 9. So if something's divisible by 9, the sum of the digits has to be divisible by 9. So if the sum of the digits, so real similar to the test for 3, is divisible by 9. Do an example. Maybe if we had like 577. So this here is going to be 19. If I do my 5 plus, I should do an equals. So 5 plus 7 plus 7 gives me 19. 19 divisible by 9? Nope. So this one wouldn't work. The 577 wouldn't work. But you agree 18 is divisible by 9? So if instead, and you can leave your notes the other way if you wanted to, but if I made it a 576, then I'd have 18 as my sum. That's divisible by 9, so then 576 would be. So kind of choose to put either example you want to or neither. The last one then, 10. Something's divisible by 10 if ends in a 0. If it ends in 0. So 10, 20, 30, 40, 5 million, anything that ends in a 0. And figure do one example, maybe two. So example then, if I have the 5,385. So is that divisible by 2? Yes or no? Nope. Because it's not even. How about 3? Well, 3 would be 5 plus 3, so 8. Plus another 8 is 16, plus 5 is 21. Because 21 divided by 3 works, right? So 3 would be 1. Answer 4. Is 4 going to work? So 4, we could look at what are the last 2 digits. 85. Can we divide 85 by 4? No. The other way is just say, well, it's not even. So 4 is never going to work if it's not even, right? And if so, for 4 you could say 85 divided by 4. Nope, that doesn't work. All right, 5. Yes, no? Because it ends in 5. 6. To be divisible by 6, it needs to be divisible by 2 and 3. Is it? Nope. So it's not divisible by 2. And again, it's odd, so none of the evens will work. 7 we didn't have a rule for. 8. Suppose you could go back to the same thing. It's an odd number, so 8 won't work. Otherwise, you could say, if you wanted to, 385. So easiest for 8 is just say, look, it's odd. But you could say, well, 385, okay, that's 320 plus 65, right? So this is divisible by 8, but is 65 divisible by 8? Nope, we're one number off. It'd have to be 64. So not 8. 9. 9 was add them all up, which gives us 21. Is that divisible by 9? Nope, so 9 is not an answer. 10, how about 10? Nope. So 5,385 is just divisible by 3 and 5. Does that seem okay to you guys? Oh, there's more. So the next sections go faster, though. Finding factors. Factors. The book kind of assumes that you know this. I'm going to write it out. But if you have a number times a number equals a number, that at some point in your math career you probably learned that that answer is called a product. And the two original things are called factors. So you have a factor times a factor equals a product. So if you wanted to, you could say, for example, if you have a 6, do you agree 2 times 3 gives you 6? So then 2 and 3 are going to be factors of 6. You could also say 1 times 6 gives you 6. So 1 and 6 are also going to be factors of 6. So 6 then has 4 factors, 2 and 3 and 1 and 6. Make sense? So this section of the notes is just how do you find factors? And then we'll do the very last section, which is how do you find factors that are prime numbers, which then 2 and 3 would work, but the 6 and 1 wouldn't. All right, so finding factors, kind of the little rule for finding those is just check for divisibility. Let's say check for divisibility, which is why we just went through all those divisibility rules. And I'm going to say until you meet in the middle. And this will make a little bit more sense when we do an example. And I picked a number that has a whole bunch of different factors, so you'll kind of want to spread things out. So the number I'm looking at is 96. So I'm going to figure out what are all the different numbers that I could divide 96 by and have that work out evenly. So you always could do 1 and the number itself, right? 96 divided by 1 works. Anything divided by 1 works. And 96 divided by 96 works. So I'm going to try to write my numbers in order. So I put 1 way on the left, that's the smallest. 96 will be my biggest. I put it on the right. 96 divided by 2, does it work? Yep. And that gives you a 48. Nice, I heard that from somebody. Because it's even. 96 divided by 3. 9 plus 6 is 15. 15 divided by 3 works. So 96 divided by 3 then is going to be a 32. 96 divided by 4. Well, 100 is divisible by 4. This is 4 less than 100, so yep. So it's going to be a 4 and a 24. Because 100 would be 4 and 25. So 1 less than this would make it 4 less than 100. All right, 5. Nope. 6. Because it's divisible by 2 and 3. So good. 6. And then the number there would be, well, 96 is 60, which would be like a 10, plus another 36, which would be 6, right? So 16. And 7, we don't have a good rule for that. No, it's not going to be divisible by 7. I guess you could say 70 plus another 26, but 26 isn't divisible by 7. So 8. So it would be 8 and, well, 80 would be 10, but then this is 16 more, so 12. Cool. 8 and 12. And then like 9, nope, because 99 would be 10, 11, 12, so we're good. So these here would be all the factors, and you guys learned that as like your rainbow thing?
And then you go from 1 to the...
So the last section is Roman numeral 4. It's prime factorization. So prime factorization. I enjoy these. The divisibility rules feel like work to me. This, I think, is a whole lot more fun. What this is doing is this is saying, well, here's all the factors, but now we're just trying to break it down into just prime numbers. So like our 6 could be broken down into like a 2 and a 3 and so on. And I think if I just say, I'll say, basically it's a way to break a number into prime factors. So what prime numbers would you have to multiply by each other to give you this total amount at the end? And the key is you do a factor tree. I'm guessing that that'll sound familiar, or at least it'll look familiar as we go through and do one. And so I'm going to pick the number 126. There's multiple ways to go through and do this. Some people like to pick bigger numbers, then break up those numbers into smaller. I usually just, if it's even, I just start with 2. Sure. Yep, so 2, and then you could say 63 would be the other one. Half of 12 gives me 6 in that tens digit. Half of 6 gives me 3, or however you do it. 63 is divisible not by 2, but by... Okay, someone sees 9. 9 and 7, right? 7 times 9 is 63. Now, can we break up the 9? Yes. 3 and 3. And 7, can we break up the 7? Nope. So now here are our prime numbers. And there's more than one way to do that as well. But so now our number is going to be 2 times 3 times 3 times 7. So the way the book writes it is 2 times 3 squared times 7. So that's like the proper way, small to low, if you have multiple numbers. Yep. And do one more example. So 210. 210, you could break that up into, okay, 10 and 21. All right, my 10, what can I break my 10 up into? 5 and 2. And those are both prime numbers, so I'll circle them. 21, 7 and 3. And those are both prime. We can't break either of those up anymore. So final answer would be 2 times 3 times 5 times 7. Maybe just one other comment. I wouldn't write it this way, but if you're feeling like, how am I going to remember that? You could do it multiple ways. For me, I tend to like doing it this way, but I can see where a lot of people maybe wouldn't. But so, because 105 isn't as nice to break up as the 10 and the 21. So your way is probably easier. But then I'd say, okay, a 5, because 5 times 20 gives me 100, but I have one more 5, so 21. And then I could say, well, that's going to be a 3 and a 7. So now my prime numbers are still the exact same answers, 2, 5, 3, and 7. So it's kind of however you feel like breaking it up. Just make sure you end with all prime numbers. That's all for the notes. Probably.